What up everyone, it's your boy Dio and this is Frontline Investment. Bionanians, how are you guys doing today? First of all, thank you to all my new subscribers, and of course a big thank you to all my old subscribers that have been with me since day one. It is not easy, guys, to make a YouTube video. So you guys, if you are new on my channel, if you haven't seen, if this is your first time of seeing my video, you guys can easily go to my channel and you can find tons of information about Bionano Genomics. I also made a video about how undervalued Bionano Genomics is, the ARK Invest opinion on Bionano Genomics, and so on and so forth. Of course, I also made a video about PACB earning reports, 2020 earnings report. So you guys can also go to this video and you can check out PACB earning report, and which is also good because if you are invested in this genome industry, you don't necessarily need to only know about Bionano Genomics. You have to know about their competition as well. So that's why I always try to incorporate Illumina and PACB Nanopore in my videos little by little, so that you guys can have idea of what is going on outside of Bionano Genomics, because this is not only about Bionano Genomics, it's about helping the world to be a better place. It's about cancer, it's about leukemia, it's about all this autism and so on and so forth, all these rare diseases. It's about helping the world to find solution to all these deadly illness and diseases. So let's go to today's video. I want to show you guys the difference between Bionano Genomics, PACB, Illumina, and possibly Nanopore. Let's get to it, guys. This video is completely about the difference between structural variant technology and sequencing technology, because most of my followers, subscribers still have no idea. I still get this question every day: Dio, what is the difference between PACB and Bionano Genomics? What can Saphyr do that PACB device is unable to do, or the NovaSeq 6000 from Illumina is unable to do? So in this video, I want to answer this question as quick as possible because time is money. So that brings me to this page right here. Okay, that brings me to this Children's National Medical Center report. As you guys can see from the top of this article, or what should I call it, case study, Saphyr found the structural variant that was responsible helping solve this case in pediatric genetic disease. So Saphyr was the only device out there, the only detecting device that these researchers were able to use to detect structural variants that was responsible for this bad genetic disease. Okay, in this autism, you guys can see this poor little boy suffering from this genetic disease. So what did Saphyr do that other technology were unable to do? What did it do? Look at this, guys. You can see Saphyr detected a 410 kbp duplication and insertion in the DMD gene, which provided a definitive molecular diagnosis for Duchenne's muscular dystrophy. That is the name of this horrible disease. You can see DMD is Duchenne muscular dystrophy. That's how I hope I pronounce it very well to you guys. So these researchers, they have used several technologies to try and detect what was wrong with this little boy. They used whole genome, whole exon and whole genome sequencing technology. We are talking about Illumina, PACB, Nanopore, whatever it is out there, whatever sequencing technology is out there, you can mention it. They were unable, these technologies were unable to detect this. Why do you think Saphyr was able to detect it? Because Saphyr is the only device out there that is able to detect structural variances that exist, from this 400,000 base pairs. No other technology, PACB machine, is able to detect, not up to this 400,000. I believe PACB is able to detect from 10,000 to 20,000 base pair, I believe. And we all know Illumina, even with their NovaSeq 6000, they are only able to, work in the base. They are in the base level. They are not even in the middle or on the top level like Bionano Genomics Saphyr is. And of course, Nanopore is also was unable to, you know, detect on these structural variances. Okay. And we can also see all this technology from multiplexed ligation polymorphism assay were also unable to detect this thing. PCR and Sanger sequencer also unable to detect. I believe this is Illumina using, I'm not really sure, I have to check this out. Okay. And chromosomal microarray was also unable to detect these structural variances. And of course, we can also see juvenile male patients suffering from muscular weakness and the developmental delay patients tested negative by standard and advanced molecular methods. So all these standard and advanced molecular methods were unable to detect what Saphyr is able to detect. Okay, and why is this a good news? Why is this so important? Okay, because if Saphyr is able to detect something, this is going to help researchers, you know, to find solution in the future to this kind of thing, or they can at least understand what was wrong with this boy, you know. And it's going to help us in the future to find cure or possible medicine for this kind of diseases. So we are just at the beginning, guys. That is why I am extremely crazy about Bionano Genomics, because people are always asking me, Dio, why Bionano Genomics? Why not Facebook? Why not Tesla? Why not? Of course, I was crazy about Tesla, but the day I found Bionano Genomics, that was the day I realized, wow, this is something extremely big and worth spending my time on. Okay, so that I hope I have managed to explain the simple difference between Saphyr device from Bionano Genomics, which of course is for structural variant detection in genomes, and the difference between Saphyr and of course all this sequencing technology. So if anybody asks you what is the difference between Bionano Genomics and PACB or Illumina, for example, you can tell them the Saphyr is the difference, because Saphyr is able to detect structural variants in genes that all these sequencing technologies are unable to detect. Okay, and all these structural variants are the reason that some DNA, you know, sequencer from PACBO, for example, can detect. Sometimes there is no change. Sometimes there is no changes in sequence. Okay, in DNA sequence, no changes, but there may be a change in the structural variation. So that is why Saphyr is very, very important, and that's why Saphyr complements all these technologies, because sometimes all these sequence technologies, of course, are able to do some things that Saphyr is unable to do. So that's why Bionano Genomics is important. You know, researchers have to use sequencing technology, and at the same time they have to complement it with Saphyr Bionano Genomics. So we are talking about billions, you know, millions, billions in the future of revenue. We are talking about billions of US dollars in market opportunity. That's why you are invested in Bionano Genomics. That's why you are watching this video right now, and that's why you have to subscribe if this is your first time on my channel. Have a wonderful day, guys. I remain your boy Dio. This is Franklin Investment. Bye bye.